Hello everyone. Good morning. Good evening. Please join the session using this code. We will wait for another 2 minutes so many students can join.
Yeah, good evening. I'm audible.
Yes, hello.
Ma'am, I have just very little query and not able to understand how we have to join on the Zoom or any other platform.
Yes, you just join the Zoom meeting and on your browser, just type joinpd.com. Can you see this on the
Yeah, ma'am.
screen?
Yeah, ma'am.
Just type that joinpd.com on your browser and
Mhm.
put this code there so that when
Okay.
we will have a question and we will ask you for the answers, so you can put there. So
Okay, ma'am.
join
I have
this PM.
okay, got it, ma'am. Got it, ma'am. I have very little query, ma'am, regarding the
Yes.
stats, ma'am. Week 5, ma'am. Actually, it is one graded assignment, EMQ. That I have seen for the first time.
For
So
EMQ, you will have a session tomorrow. You can ask the queries there. There will be
okay.
different session dedicated to this EMQs.
Okay, ma'am, can you let me know, ma'am? Just I have very little query, ma'am. If none of the ma'am options suits the answer, fit into the answer, we have to left it blank, or what else we have to write?
Okay, actually, I'm unaware about that, so you just ask tomorrow. That will be better.
Okay, ma'am. At what time, ma'am, that will be there?
Uh, it's there on the schedule, I guess.
Come again?
It's there on calendar, no?
Okay, ma'am. Thank you.
Okay. Yeah. Please join everybody at peer deck. I can see 34 participant and only 18 has joined.
Excuse me, ma'am.
Yes.
Ma'am, do qualifier students need to solve VMQ assignment in week 4?
Actually, I am not aware about these things, so please contact tomorrow. There is a session. You can have doubt session also there, and
Ma'am,
yes.
ma'am, I have a query and a question. Can I please ask, ma'am?
Okay.
Ma'am, yeah.
Actually, we have to start this solve with the session today first. Then we will have your queries, because for queries we have different session. No? Is it from week 4?
No, ma'am, it's from the previous week, graded assignment.
Okay. For that we have another session, complete whole session where we will discuss these things.
Okay.
So, okay. So we are starting this session. Okay. Okay. and rest of the student who has not joined yet, please join through this. This is the link. You have to just type joinpd.com on your browser and write this code. You will be able to join. Okay. So you can answer in between the session itself. Okay. Let's start then. Okay. Keep your notebook and pen ready for solving the problem. We will have some questions and you have to answer in the call itself, okay, in the meet itself. Let's start. To join, I have can you see this link on the screen, this joinpd.com, and there is one code also. Whoever are joining late, please join through that link and code. Use that code, okay? Okay. So row relative frequency and column relative frequency. So what is row relative frequency and column relative frequency? You guys have watched the week 4 lessons. We will just revise and then we will do some questions on that things, okay? So row relative frequency. The two-way relative frequency for rows are obtained if the entries in each row of table are divided by the total for that rows. Okay, what we have in contingency table, let's, for example, we have some two type of categorical data. Okay, categorical data. Okay, let's say gender, male and female, okay. And another categorical data we have, are they graduated or not? Okay, yes or no, like that. So we form a table like this, right? So what is an row relative frequency and column relative frequency? We have some values here, like some number of we have some number of females and males given in the data. Let's say some number of let's say I'm just taking any random numbers, okay? Some 20 males are graduated, and some 40 males are not graduated out of 60 males, okay? And some 10 females are graduated and some 10 are not graduated, okay? So what is row relative frequency in that case? The total number of males are 60, the total number of females are 20. So what is relative frequency here? We just divide this entries with this total number of rows, okay? Total of row. This is what our row relative frequency, 20 by 60, 40 by 60. Here 10 by 20 and 10 by 20. This is row relative frequency. So this is what row relative frequency, and similarly for column relative frequency also, we just sum up the total. This is 20 plus 10 is 30. This is 40 plus 10 is 50. Okay, so when we are like checking about the column relative frequency, we will divide each column entry with total
Hello,
columns.
ma'am.
Yes.
Ma'am, your voice is very good.
Oh. Okay.
No, ma'am, it's okay. It's okay.
Oh, okay, fine. So this is column relative frequency. Okay, we will do some questions here regarding this topic. So if you have any doubt related to this, we will check there. Okay. Okay. So
Ma'am, in activity 4.6, question number 3.
Actually, we are doing here solve with the session. For rest of the question, we will be having a session. You can ask your questions there, like every assignment question, tutorial, everything you can ask there. So today's target is first to, like, we will solve some questions here, then you ask your questions. Okay.
Ma'am, I'm not able to join the peer deck. I tried several times, ma'am.
Oh, wait.
QNF now, PLQ.
Just type, just joinpd.com. Okay, have you, like, or
Yes, ma'am, I tried, but it's showing couldn't find a session for QNF. Don't know why.
couldn't
We
find?
just type QNFPLQ without
Yeah.
space.
Yes, without space.
Somebody have also dropped the link in message chat, meeting chat.
Yeah, ma'am, joined.
Is it join? Yeah. What were you saying? Sorry. Okay. So the next thing is, you are able to join, right? No.
Yes, ma'am.
Okay. So now association between two categorical variables. If the row relative frequencies are similar for all the rows, then we say that.
Ma'am, your voice is very slow.
Yes, ma'am.
Hello. Is it okay now?
Yes, ma'am.
Yes, ma'am, now it's fine.
Yes, ma'am. It's okay now.
Okay, fine. If the row relative frequency are similar for all rows, then we say that the two variables are not associated with each other. Otherwise, we will say, okay, if they are different, then we will say, okay, they are associated with each other. We will see some questions regarding this, so this concept will get clear. Okay, so let's move to questions. Okay, can you see the question on your screen? Hello.
Yes, ma'am.
Okay.
Yes, ma'am.
Consider the question is, consider the following survey questions that if you own at least one credit card or not, was asked from 3 different samples of Washington State University student. 100 was freshmen, 100 sophomores, and 100 seniors. Question is, what proportion of total students are sophomores? So there is a data given about credit card, how many students have credit card, and they are asked. So this is the data that 42 freshmen have credit card and 52 do not have. And the question is asking about what proportion of total student are sophomores. Okay. So I would like you guys to try first, then we will discuss the solution.
Okay.
Done, ma'am.
Okay. Okay, let's wait for others, then we will. Yeah. Okay, so what will we do here?
Ma'am, first will we calculate the total number of sophomore students and divide by the total number of students.
Okay. So we are asked to proportion of sophomore students. So the task is to first calculate the total number of students, because to find the proportion of sophomores, we need total number of students first. So,
Ma'am, again, your voice is very low.
hello, is it okay now?
Ma'am, your voice is turning low after something.
Yes, ma'am.
Oh, sorry. Is it okay now?
Yes, ma'am.
Yes.
Much better.
Okay. So we will first calculate the total number of students, which is number of freshmen plus number of sophomores plus number of seniors, right? And then total student is 100 plus 100 plus 100, 300. So to calculate number of proportion of sophomore student, we will just have this 100 by 300. Okay. Okay. Any doubt here?
Oh, no, ma'am.
Okay.
No.
Let's move to next question. So this question is about the same data you have. This now they are asking about what proportion of total students do not own a credit card. Okay. So now again you guys first try, then we will discuss.
Done, ma'am.
Okay, just wait for this. Okay. So to calculate the proportion of student not having the credit card, we first need to calculate the total number of students. Okay. So that we have already calculated, that is 300. And number of students who do not own a credit card, how will you calculate that thing? So you already have this in your table. From table you can go with the this number of students.
Ma'am, can you speak loud?
Oh, sorry. Hello. To get the number of students who do not own a credit card, we will see in the table. And table we can see that this entry is 58 plus 45 plus 19, that is 122. So proportion of student not having credit card will be 122 upon 300. Is there any doubt till now?
No, ma'am.
Okay. So let's go to next question. So again, the next question is like on the same data, what proportion of student who owns a credit card are freshmen? Okay. So first try by yourself.
Done, ma'am.
Okay. Yeah. So how will you do that? First, we have to calculate proportion of student who owns a credit card are freshmen. So how will you proceed?
Ma'am,
Just-
first we will check total number of freshmen, and means we will divide the who are freshmen and own the credit card, divide by total number of freshmen.
First, we will check how many students have credit card. So we will
Yeah.
calculate this 42 plus.
Ma'am, shows the answer.
Yeah. So 42 plus 55 plus 81. And we will divide it. And we will have 42 upon the sum. Yeah. Is it okay for everyone? Okay. This is point two.
Once again, can you repeat again?
Sorry.
Can you repeat again, ma'am?
Yeah. We have to calculate the proportion of students who own a credit card are freshmen. So first we have to calculate how many of student have credit card. So we will go to the table credit card response who said yes. Okay. 42 freshmen, 55 sophomores and 81 senior student have credit cards. So we will just sum this. Okay. How many people have credit cards? So this sum is
178.
yeah, 178. Total of 178 student possess a credit card. But what we have asked the proportion of student who owns a credit card are freshmen. So this proportion is nothing but equal to number of freshmen having credit card
Divided
upon
by
total. Yeah, total
yeah,
number of student having credit card.
credit card.
So it is 178. So what is the total number of freshmen having card? This is equal to
40.
42 by 178, right?
Yes.
0.23.
Huh. So this
Okay.
you have to just calculate this 42 upon 178. That's
0.23.
yeah.
Yeah.
0.23.
Oh, 0.24, right? Okay. This is just a calculation.
Yes, ma'am.
Oh, let's see next question. What it's saying is row relative frequency similar for all the rows. So you have to calculate the row relative frequency for the question. Let's try by yourself first, and I will. Those who are not able to answer the question, please join this joinpd.com like Peerdeck. And here is the code. Please join through that code. Yeah, please type joinpd.com on your browser, joinpd.com. Okay, I will put in the chat. Okay. Yeah, someone has already.
Ma'am, can you use calculator in the exam?
Sorry.
Will we get calculator in the exam?
Okay. I have no
Yeah,
idea.
yes, you can use
Yes.
calculator in Excel.
And the code is written on the screen. Please, without space, you have to put the code, then you will be able to join. Okay. So I hope everyone has done with the question. Do you need more time for this?
No, ma'am.
Okay. So the question is row relative frequency similar
Ma'am,
to
your voice is low.
Okay. Row relative frequency. We have asked to calculate row relative frequency. To check whether it is similar or not, you have to calculate the row relative frequency for everything, for every data here. So what will you do? You have to just sum up first this row. There are two rows, this yes and no one. So you have to just calculate first
170.
the sum of first row, and then you have to calculate this second row sum. The sum is
Different.
after like we have to do this 42 plus 55 plus 81. This will be 42 plus 55 plus 81. This will be
178.
178.
178.
178. Okay.
Yes, ma'am.
And for the second also we will calculate the same.
122.
122.
122.
It is 178. This is 122. So the next step is to calculate the row relative frequency. You have to divide this 42 with divided by 178 and calculate the value.
Individual.
Yeah, individual. We have to calculate individual division. We have to divide 81 by 178 and just check the value whether they are same or not. But the question is where you will compare this value, right? It is row relative frequency. So where to compare? With along the row.
Column.
Yeah, exactly. You will just check the values with row 1 and row 2. Are they similar for the same column?
No,
And
ma'am.
if they are same, then your answer is yes, otherwise no.
No.
Okay.
The answer is no.
So yeah, see. So I hope you guys have calculated. The values are like that.
Yes, ma'am.
So see, for the first row, the value is 0.25, 0.24, sorry, here. And the second row, the value is 0.48, row relative frequency is 0.48. And for the total of this column, the row relative frequency is 0.33. So we can
How many?
clearly see that, sorry.
When we add it, then we get 0 point something, not 3.
Sorry. What are you saying? Your voice is not clear. But yeah.
Ma'am, how total is 0.33?
Yeah,
Like when adding it.
it's different, ma'am.
Yeah. The calculation mistake might be there.
Yeah.
Oh. So generally we have to see that, but we can clearly see that this row 1 and row 2 relative frequencies are not same. So we will just say the row relative frequencies are not similar. Okay.
Yes, ma'am.
Yeah, that's all. Okay. It was just about the calculation only. Yeah.
Ma'am, I have a question.
Yeah, please.
Ma'am, there the answer is yes. If only freshman column frequency is same and yeah, all three the same.
Yeah. When all three will be same, then the answer will be yes, row relative frequencies. Generally, we see we are mainly focused on this categorical variable, not for total. So when if two rows will like if there are two rows and relative frequency for both of these two are same, then automatically this total will also get the same value only.
Yes, sir.
But the total is correct here. It's not
Huh.
wrong.
Yes.
Uh,
Okay then. So we'll move to next question. So the question is
No,
Ma'am,
column.
can you, ma'am, can you show the solution once, please?
Yeah, sure.
Yes, ma'am. Thank you.
ma'am,
Okay. Yes.
ma'am. In please show the frequency, relative frequency of the system. Yes.
This is
If in freshman column,
sorry.
24
Huh.
in freshman column is 24 is suppose that 40 0.48.
Okay.
Then it is yes, answer yes, yeah. If all columns are same.
All columns. You have to check with the all columns.
If
This
only freshman column
all
is same, that is not answer.
and that's not.
Yes.
Yeah. You have to check with this column, column 1, column 2, column 3, all. Then only we will say that row relative frequencies are similar for all rows. See, the question is for all rows
Oh, ma'am.
because
Uh,
when this row relative frequencies are similar for all the rows, then we can have like, we can infer something from that data that the
yeah,
two
yes.
variables are not associated with.
Associated, yes.
Yeah.
If ma'am all column is same, then we consider that association is not.
Yes.
If
Ma'am,
any
here,
one column is different, then its association is.
Yeah.
ma'am, here if it's any like freshman will be 4.48, then then it will not be similar now because
Yeah.
0.46 and 0.16 are
Yes.
not similar.
Yes, exactly. We will have such a question also in next slides. Okay. See. So should we move to next question now, or you have any doubt?
Yes, ma'am.
Okay. So the next question asks for the column relative frequency of the are it similar or not, or same or similar. So the same question, but approach will be same. Just you have to calculate column frequencies now.
Done, ma'am.
Okay, just let's wait for other.
Ma'am, answer putting option is, I think.
Hello.
Yes, ma'am. Answer putting option is not open.
Is it with everyone?
What, ma'am?
You have to join first, like.
Yeah.
No, I am also joining, but I have I think
Let's see.
Then it should be open actually.
yes,
It might be some internet issue from your side.
yes, I got it.
Okay. So to calculate column relative frequency, we have to just find the sum of each columns first, right?
Yes, ma'am.
Then we will divide each entry with that sum.
100.
Yes, column sum. This column sum we already know, right? This
Yes.
is
Yeah,
100
all
because it is
100.
given that the total number of student in freshmen are 100, total 100 sophomores, total 100 seniors are there. Okay, then we just have to divide everything with the 100 because every column sum is 100 only. So it was quite easy calculation. And then we just have to see whether these relative frequencies are same or not. So we can directly see from this 0.42, this is 0.55, 0.81. They are not similar, right? So we will this time we will compare along columns. This 0.42, this will be 0.42, this will be 0.55, this is 0.81. So we can directly see that they are not equal, they are not same.
Yes, ma'am.
So the answer is no, right? The column relative frequencies are not same or similar for all columns. Okay. Anyone have a problem here? Any doubt from this till now?
No,
Okay.
ma'am.
So yes, let's move to next question.
Ma'am,
Yes,
please move to the previous slide.
sure.
If we added to 0.42 plus 0.52 as all three columns, then we get 111, 31.
Yes, yes.
Then it will same
Just a
for
mistake.
column relative frequency.
Uh-huh. So what's your question? Can you please repeat?
Just like a mistake.
And total sum is incorrect, I
He
think.
just pointed out that mistake.
Yes.
Nothing else.
Okay, then please mute your like mic, otherwise it will be disturbing others. Okay then. Yeah. So the next question is there an association between the year of study and owing a credit card? So how will you do that? So let's try by yourself first.
Right.
Ma'am, please repeat the previous question, column relative frequency.
Okay, we will see that question in some time. Okay, first we will discuss.
And your voice is also too low.
Still. Okay.
Man, your voice is good. I think no
It's
problem with
audible
voice.
means it's not that.
It might be like internet issue from your side. Please check if it is okay
No,
for
ma'am.
others.
No,
It's
ma'am,
5G.
it's low.
Oh,
It's
okay.
from your side.
Then I will check. Okay, so we have asked here association. So how do we check the association between any two categorical data, right? So here, year of studies is freshmen, sophomore, seniors, and having a credit card is yes or no. These two are categorical variables here, right? So they are asking us whether they are associated or not. Having a credit card, does it depend on the year of study of the student? So what we have to calculate? There are two ways. Either you calculate the what row relative frequency or column relative frequency, right?
Yes, ma'am.
Row relative or either
Column relative.
yeah column relative frequency, and just check either they are same or not for all the rows. If you are checking the row relative frequency, then check the row relative frequency of every row for all rows, right? And if you are checking for the if you are calculating the column relative frequency, then then check for each column. If they are same, then there is no association. If the row relative frequency for all the rows are same, then we will say that there is no association between the two categorical data variables. Otherwise, there is association. So in our question, we already have calculated both row relative also we have calculated, and also calculated the column relative frequencies also, right? So from that data we can conclude that our categorical variables are associated with each other. Okay, so anyone has doubt in this concept, then please ask here.
Ma'am, how to calculate association?
For association, we have to check row relative frequency of the table of the data.
Yes, ma'am. Then
Row relative frequency. So in the previous question, we have calculated the row related frequencies.
yes,
Right?
yes,
Huh.
ma'am.
So we will just move to that slide. So you will get, you can observe there. See, we had calculated here. This was the row relative frequencies, right?
Yes, ma'am.
So we will just check are the row relative frequency same for all the data, all the rows, like for the first row, second row, like that. This is
Here is
for
different.
here it is different. So
Yes.
Yeah.
the concept is when your row relative frequencies are different like this, then you will say yes, there is a association between two categories, this having a credit card and year of studies. In case when this row relative frequency are equal for each and every row, for this row 1, row 2, row 3, let's say all are 0.24, here
Yes.
all are 0.37 something, then we will say our two categories, this having a credit card and year of study, are not associated with each other. Okay.
Yes,
So we have two ways. Either you calculate row relative frequency or you just calculate column relative frequency, right? So
Yes,
we
ma'am.
already have calculated both.
If
So-
one of them are similar, then is associated, and one of them are not similar, then it is association.
Yeah. But actually it is either way. You just calculate one of them. It's
Yes.
like that. Yeah. Okay. So whatever you like to calculate, row relative or column relative, you just go for that and just take it. Okay. So in our case, the variables are associated. Yes, please.
Ma'am.
Yes, ma'am.
Okay. Okay. There is another question like new data set now. There are two factories, say A and B, which produces a square shaped wooden sheets of varying length of sides. Okay. The data is given for the factory, measure of sides, area of wooden sheet. What is the population standard deviation of measure of sides. Okay. So I would like you guys to try first. Then we will discuss. We just have to calculate population standard deviation of the measure of sides of that wooden shapes. Okay, hello. Is my voice is clear now? Hello.
Yes, ma'am.
Okay. So the question is to calculate the population standard deviation of the measure of sites. So we are now interested in this data set only, right? We have to calculate the population standard deviation. So to calculate the population standard deviation, we first want to, the first need is to know the formula. So what is the formula for population standard deviation? Let's say it's sigma x.
Sigma xi minus
Then
x
it is summation of, yeah, xi minus x bar the whole
more
square
upon
divided
number
by
of
n minus 1 or n.
ma'am n
Yes,
Only n.
only
Only
n.
n.
And this is square root, right?
Yeah.
Okay. So this is our population standard deviation for the measure of sites. So we just have to take care of this data only. So just find out the mean and just calculate. Okay. So, yeah. So the mean is the sum of all the entries of measure of site, that is 2 plus 3 plus 5 plus 2 plus 3 divided by 5, right? Number
5,
of
yes.
observations, that is 5. That is 15 by 5, it is equal to 3.
3.
Fine. Yeah. Then we have to calculate what? Xi minus x bar. So your x bar is 3. Your xi values are this 2. So this is 2 minus 3 minus 1, 3 minus 3, 0, minus 3, minus 3, minus 3, right?
Yes,
This
ma'am.
is xi minus x bar, and you have to just square it and sum it. The sum is 6. Fine. So 6 divided by 5. That is your square root of 6 divided by 1.095. Okay. This was the calculations. Okay. Is it fine for everyone?
Yeah, ma'am.
Yes, ma'am.
Okay, then let's go ahead.
Excuse me, ma'am.
Yes.
Ma'am, my answer is 1.20 or 1.2. So how
Also take root on it.
1.095 is coming?
Root of 1 point square root.
Root.
Just notice that we have to
Okay,
calculate
ma'am.
standard deviation, not the variation.
Okay, ma'am.
Yeah. This is just a very common mistake we do. Just take care of it when standard deviation is asked. Just don't forget to take a square root. Okay. So the next question is, what is the sample standard deviation of measure of sides? Okay. Let's try it first, then we will. You have to enter the answer till 3 decimal places. Okay, done. For a sample standard deviation, what we have to do?
And
There's
minus
just a slight change. Yeah, there's just a
N minus
slight
1.
change. Yeah.
N minus 1.
Yes, your sample standard deviation, let denote by Sx, then it is equal to square root of summation xi minus x bar the whole square divided by n minus 1. But you have calculated half, like the value of sigma x, then you either do this way or you can go by this way also. Square root of n divided by n minus 1 into sigma of x. This will also give the same answer. Okay, let's see the solution. Okay. Yeah. So this will also give the same solution for you. Why it is so? Because this thing is equal to square root of n divided by n minus 1 multiplied by what is sigma x? It is square root of summation xi minus x bar the whole square divided by n, right? So this square root n get cancelled and whatever you have calculated is correct, right? Is it fine?
Yes, sir.
Oh,
Yes, ma'am.
so yeah, what is the next question? What is sample standard deviation of area of wooden sheet? So just look at your data. There is one thing, area of wooden sheet is also given there. You just have to calculate the sample standard deviation for this data now. Right? Okay, hello. Hope you guys have tried this. Yeah. Okay, fine. So we have to calculate again a sample standard deviation of area of wooden sheet. We will consider this data set now 4925 49. Okay, so the same procedure we have to follow. First we will calculate the mean of the data, then we will go for the difference, the variation, and then we will just put all these values in this formula and we'll get the solution. Okay, so first we will find the mean of this data, that is 10.2. Our n number of observations are 5, but we are asked to calculate the sample variation, so we will do n minus 1, that is 4. So just calculate the xi minus x bar, the whole square. This is 298.80. So just calculate 298.80 divided by 4, which is 8.643. Okay. Any doubt here? Okay.
No.
Hello. Huh. So now we will move to another next
Yes,
concept.
ma'am. Why your voice is too low?
Hello. Still it is low. Hello.
Yes, ma'am.
Yes, ma'am.
Let me check. Hello.
Ma'am, it's low.
Huh? Is it clear now?
It's clear, it's okay, it's
Fine,
audible
ma'am.
also.
Actually, I think they have.
Yes, ma'am, please continue. It's okay.
Ma'am, please continue, it's okay.
Okay. So let's move to the next concept, the covariance and correlation. Okay. So covariance. So when there was a numerical data, numerical variables are there in the data set, then to check to check the association of the data, we used to plot scatter plot, right? Sorry. So what scatter plot does, it just point out here all the pair in a graph. Okay, but this to check the linear or strength or extent of linear association of this numerical data, let's say this is my numerical variable 1, this is my numerical variable 2 n2, and this is some data, let's say data point, this is my scatter plot. Now I want to calculate the strength of linear association between these numerical variables n1 and n2. So this scatter plot will not give me the same, right? This will just give me visualization of the points or data points, right? So there is a concept of covariance which quantifies the strength of linear association between numerical variables. Okay, so we have one formula for that. We will just calculate and find the linear association. But you know that what is the covariance formula? Anyone? Okay, covariance is nothing but the summation of
Summation of xi minus
xi minus y
X
bar
bar
into y
x
minus y bar
minus y
by
bar
n minus by
n
n minus
equal
1
to
and minus 1.
n minus 1 for sample.
yes, divided by n for population, n minus 1 for the sample
Sample.
variation. But you know, this x and y are nothing but your numerical variables, right?
Yes,
This
ma'am.
is numerical value, this is also a numerical variable. Let's say there is some data, let's say age of student. So age will be in years and height of the student, which will be in centimeters. So we know that xi minus x bar, these have unit of years.
Yes,
This
ma'am.
has unit centimeter.
Centimeter.
So this product will have unit some year centimeter. This do not make sense, right? So even though this value give us a linear association between these two variables, but still uh, it's not that much good. So we need some unitless measure for linear association. So we'll go for the correlation. So what is correlation? So correlation is also a measure of linear association between two numerical variables. For that we have this formula, Pearson correlation coefficient is this one. Here you can see on the screen, or we can calculate this as a equal to, let me clear this first. Just, yeah, for correlation what will you do?
Divide covariance
You
by
will
the
just divide
product of the
covariance.
deviation.
Yeah, you will just divide covariance of x and y to standard deviation of
X and Y.
x and standard deviation of y.
Why?
This will give you a correlation. Generally, the correlation values lies between -1 and +1. Okay, the range of correlation values are -1 to +1. It do not exceed these values, right? But for covariance, there is no limit, right? If correlation is positive, correlation is 1, then what does it mean? There is a strong linear relation between the two numerical variables. Right?
Strong and positively.
Yeah, strong positive. Yeah. So we will do some questions based on covariance and correlation now.
Ma'am,
Yes.
when do we say there's a weak relation between two variables?
Yeah. Weak relation.
Between -0.25 to positive 0.25.
Yes. Actually, in that case, we will say that there is actually no relation. Till then, we can have one question. There is one question also dependent on this strong and weak relation. We will explain there also. So let's go for a next question for time being.
Okay.
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 So the question is, the same data you have, what is the sample covariance between the measure of side and area of wooden sheets? Okay. You have to calculate the covariance between measure of side and area of wooden sheet. So you have two data sets, measure of side also there and area of wooden sheet also there. Hello. Yeah. So you might have calculated this sample covariance between measure of sides and area of wooden streets. So what we will do, we just calculate the mean for this data set first. Let's say this is X and this is Y. Then we will first calculate the mean of this data. This is X bar. We already have calculated this, right? Xi minus X bar. And similarly, we also have calculated Yi minus Y bar for this wooden sheet, area of wooden sheet. So you already have this sum. Then for covariance, what is the formula? The product of these two variants divided by n minus 1. Why n minus 1 is there? Because we have asked sample covariance. We just put these values, we just multiply xi minus x bar and yi minus y bar and sum over this 5 values and divide it by 4. The covariance value is 10.5. There was a calculation. If there is any doubt, please tell me, so I will describe it. Hello.
No, ma'am.
Okay, so we'll move to next question. Okay. See the question you were asking for. What can you say about correlation between the measure of side and area of wooden sheet? So, yeah. So generally, this correlation values are correlation takes the values from -1 to +1. Let's say this is my range, -1. This is 0. This is 1. This is my correlation values. If my correlation values, so I will just divide it in some segments. Let's say this is negative 0.25. This is negative 0.5. Okay. I want to divide in one more fragment also. So I will remove it again. Yeah. So let's say it is like this. Here it is 0, some 0.25, 0.5, 0.75 and 1. Similarly here, negative 0.25, negative 0.5, sorry, yeah, negative 0.75 and negative 1. These are my correlation values can be taken. So whenever your values lies between 0.75 to 1, we say the association is what? Strong and positive, right? It is strong, positive. Positive. Similarly, if the range of your correlation lies between negative 7.5, negative 7.5 to negative 1, then we will say it as a strong negative. Strong negative. For the range between 0.5 to 0.75, we will say it is
Moderate.
Yes, moderate. So yeah, here
So
also
moderate and positive.
moderate positive. This is moderate negative. Right, negative. Similarly, this 0.5 to negative 0.25, we will say it as a weak correlation, and weak negative here. And for this part, this positive part, negative 0.25 to 0.5, if it lies between this range, then we will say it as a weak positive correlation. And if any values of correlation lies between this area, what will say?
No relation.
Yes,
Absence of relation.
Absence of relation or no relation. Okay.
Here,
So,
moderate and reasonably means same, ma'am.
sorry. Yes.
Like moderate.
Yes. moderate and reasonable, we can consider them as the same.
And ma'am,
Oh,
do like we include the endpoints values like 0.75 and or 1, like, or the between values?
yes, generally we take this endpoint like 0.75 to -1. So we consider -1 inclusive, 0.75 also, like 0.75 is not included in that. So the lower limit is generally is not included. Okay. So now try this question. Here we have to calculate what can you say about the correlation between measure of side and area of wooden sheet. So this is your x's, this is your yi's. Just you have to put the values in the formula and calculate, and to see where your values fall, in which range it falls.
Done, ma'am.
Done. Okay. Do you understood that inclusive and exclusive points? Like if your R value belongs to, let's say 0.75 to 1, then if your R value is 0.75, then you will say it as a moderate. This value is not there, is not considered. But if R is equal to 1, then you will say it's a strong positive. Here you will say moderate positive. Okay.
The 0.75 is not included, no?
Yes.
Okay.
Generally, lower limit is not included. The upper limit is included, inclusive. Okay.
Okay.
Okay. So let's check about this
Similarly,
answer.
0.5 and 0.25 will also be not included for the second intervals.
Sorry, what you 0.25 and 0.5?
Yeah, like for the second interval, 0.5 to 0.75,
Huh.
0.5 will not be included.
Yes, exactly. If R is your 0.5, then you will say it is a
Weak.
weak one. Okay. But R is equal to 0.75, then
Moderate.
moderate.
Okay, ma'am.
Okay. So let's check its answer. So covariance you guys already have calculated, right? So you have to calculate the standard variations. That also you have calculated already. I have to just put the values here and calculate. Is it okay if it is, so your correlation value is 0.993. Where does it fall? It lies between
0.75 to 1.
Yeah, it lies between 0.75 to closed interval 1. Generally we write it as like that. So 1 is inclusive, this is exclusive. Okay. So 0.993 is there, so it's a strong positive relation. Okay, correlation. Fine.
Yes.
Okay. Anyone have a doubt here? Then otherwise we can go ahead. Okay. So the next question is, first we will see what is point biserial correlation coefficient. So it is also measure, like we measure the strength of association between the numerical variable and categorical variable with two categories. Okay. Till now what we have seen, like we have seen the association between two categorical datas, right? Two categorical datas, two numerical datas, two numerical variables, right? So now if there is a combination of one numerical and one categorical variable, but such that your categorical variable has two variable only, like it is like, for example, there are only two categories in that categorical variable, then to measure the strength of association between these two variables, we have to use this point biserial correlation coefficients. Okay, for this the formula is like that. So what does it mean? So let's say there is some categorical data. Let's say, for example, you have a gender, okay, and we want to calculate the number of graduates. How many males are graduate, how many females are graduate, okay. So this is gender is your categorical data, right? This will be a categorical data, and we are considering let's say we will calculate the marks, let's say scores of the students in some exam out of 100, okay. So the data will be like, there is gender for the student and marks will be there. So we are being to ask what is the point by serial correlation. Then we first have to calculate, let's say some male female data is there and some marks are also there. Let's say 97, 95, 40, 49, like that marks are also there. Then what we are supposed to do, we have to first divide the whole data into two categories. What are the two categories here? Male and female. So just give anything as a number 0. Let's say for male data, I will say that data is Y0. So I will collect all the datas for M. This is 1 and this is 2. So number of data points for M is 2. So I will calculate the Y0 bar first, because in the formula I need mean of Y0 bar and mean of Y1 bar. So what is Y0 bar? Y0 bar is the mean of data corresponding to this male part, okay. When gender is male, then we will consider only that data and calculate the mean of that. That is 97 plus 40 divided by 2. Similarly, we will calculate Y1 bar. Y1 bar. What is Y1 bar now? Now, this is the mean of the data for females, like mean of the marks that is scored by female students, okay. So this is my Y0 bar, this is my Y1 bar. And similarly, you have to find this, what is this P0 and P1. So this is proportion, actually, proportion of observations. So P0, 0 denotes my number of males, okay. So number of male students divided by total number of students. This is what P0, sorry, total, okay. Similarly, P1 is number of female students divided by total. This will give me the values of P0 and P1, and then we will calculate the this point by serial coefficient, okay. So we'll do one question so this concept get clear, then we'll see. Yeah, so there are two factories, A and B, which produces the square shaped wooden sheets of varying length of sides, okay. Is a measure of sides weakly influenced by factory. Do you got the question? The question asks, is the measure of sides weakly influenced by the factory? So what are the categories now?
A and B.
Yes.
A and B.
So here we have two categories, A and B, and the question is about measure of sides. This is A, this is B. Okay, so you have to just classify this and then find out the values and put in the formula, so you get the coefficients. Okay, so just try by yourself, then we will discuss it again. Those who have doubt, please ask.
Ma'am, can you please show the formula once again?
Yes.
Can you show the question?
Can you show the question?
Is it okay? Are you guys able to solve it?
Yes, ma'am.
Okay. Okay. So we have to find is the measure of side of the wooden weakly influenced by the factory. So yeah, what do we
Ma'am,
do?
your voice is low.
Hello. Yeah. Sorry. Is it
Yes.
okay now?
Yes, ma'am.
Yes,
It is
ma'am.
okay.
Yes.
So were you able to do this question?
Yes, ma'am.
Yes.
Yes, ma'am.
But many less number of people have replied. Okay.
No, ma'am.
Try to get replies. Okay. Let's try. So what we will do to find this? Okay, we have here one categorical data, that is this factory, right? This is our categorical data and this is
Yes,
our
ma'am.
numerical one, right? Numerical. Fine. So what will you do first? You will just collect all the data for A. Let's say we will denote A as a 0. Fine. The manufacturing by factory A is, we will denote it 0, 0, 0, and this is also a 0. And for B, I am assigning 1. It's not compulsory. You can give 1 to A and 0 to B. It's totally depends on your choice. That is not that much considered. Okay. So we need first P0 proportion for the observations, right? P0 is what? Number of factories A out of the total number of observations. So how
3
many?
by 6.
Yes, 3 by 5, no? Why 6?
5, ma'am.
Oh,
Yes,
sorry, 5.
3 by 5, which is
0.6.
0.6. Yeah. And for P1, we will calculate the number of factories B.
2
divided
by 5.
2 by 5, it is 0.4. Okay.
0.4.
Yeah.
Yes, ma'am.
Then we need the mean for measure of sides manufactured by factory A. So that we will denote by y0 bar, right?
Yes.
This will be what?
2.66.
2 plus, yeah, 2 plus 3 plus 3 divided by 3, which is
Yeah.
equal to
2.66.
2.66. So can we write it as a 2.67 because 666 will repeat, right?
Yeah.
Yeah. So y naught bar is your 2.67. What will be y1 bar? So you just
3.5.
yeah,
3.5.
5 and 7, yeah, 5 plus 2 by 2, which is 7 by 2, and which is 3.5. So yeah, what is left then? Sigma x.
Sigma.
Yeah. So what is this? Standard deviation. So we will consider it as a population standard deviation
0.09.
for this. Yeah. What was it that we already have calculated in last questions? What was it?
09.
Yeah,
09.
0.95. Okay. So just
Yes,
we
ma'am.
have to put these values in the formula. The formula is here. Like it is y naught bar minus y1 bar divided by sigma x, right? Multiplied by square root of p0 p1. So what is the value then?
Minus 0.36.
Minus 0.36. Okay. Then can you tell me what is the, sorry, can you see my screen? Yeah. Then it is 0.36. So what should be the observation then? Is it a weakly correlated or what?
Strong negative.
Huh? So your R value is what? Negative 0.36 or 366, na? So it is 0.37, I will consider. So if it is a negative 3.7, what will you conclude about this value, this correlation then?
Weekly.
Yeah, weekly. What? Negative, right? Weekly negative.
Does the
So
answer of this question in negative?
Yeah.
yes. Generally, when we calculate this thing, like point biserial correlation coefficient, then this answer may differ person to person. Why? Because someone will take, okay, I want to give this sorry, A as a 1 and B, factory B as a 0. Then what will happen? Your y0 minus y1,
Weekly positive.
yeah, it will be weakly positive. Why it is so? Because of that difference. In formula, you can see there is a difference. What is R is equal to, sorry, RPB is equal to, what it is? Y0 bar by minus y1 bar divided by sigma x into square root of p0 and p1. So you just notice this y0 bar and y1 bar, that only decide your sign of the value of correlation coefficient, right? So some people will give this A as a 1. Then what will happen? Their y0 bar will be greater than y1 bar, right? And some will give A as a 0 and B is a 1. Then their y1 bar is greater than y0 bar. So when your y0 bar is greater than y1 bar, then your RPB will be 0.37. The value will be same, but sign will get changed. So generally, we ask here as a weakly, is it influenced by weakly or strongly? Like that, strong, weak, moderate, not like positive, negative. Okay. So
Yes.
even though your answer is 0.37, you are correct, because the question has asked, is the measure of side weakly influenced by factory? So 0.37, even if 0.37 is there or negative 0.37 is there, What is the difference? It is weakly positive and this
Weakly
is
negative.
weakly negative, right?
Yeah.
But here we do not consider sign as a big deal. Okay.
But in the qualifier, it will be given as no, that will be 1 or 0.
Yes, either they will mention precisely what is
Ma'am,
your 1 and what is
if
your
the
0. Yes.
ma'am, if the in between 0 to 0.25, then what was it?
Sorry, 0, 0.2. What is it? Actually?
0.25.
Okay, your correlation coefficient, right? You are talking about that. If it is 0.25
Yes, ma'am.
instead of 0.37. So, we have discussed it, na? If it is, it lies, you told it as a RPB is equal to 0.25, na? Then we will say there is no relation, no correlation, no like absence of relationship or no linear relationship like that. Because we do not
In
consider the
between
lower limit.
0.25 to 0.5
Then it is weekly.
weekly
Weekly, yes. 0.25
positive.
to weekly positive, yes. 0.5 to 0.75, it is
Moderate.
moderate. Yeah.
Yes.
Okay. This is moderate, this is weak. Fine. And above that, it is strong. 0.75 to 1. It is strong correlation. Okay. Is it fine? Okay. So this was the last question for today.
Yes, ma'am.
If you guys have any question there, please ask
Ma'am?
me. Yeah.
Ma'am,
No, ma'am. Thank you, ma'am.
then what if it's between 0 to 0.25?
0 to 0.25, there is
Absence of linear
relationship.
relationship.
0 to 0. 0 to 0.25.
Yeah, absence of linear correlationship.
Ma'am, if value comes greater than 1, so
It is only -1 to 1 only. This can take values from -1 to 1 only. Greater than
Ma'am, your
1.
voice is very
We can't have correlation value as a greater than 1. It's not possible. The range of correlation is this only.
yes, ma'am.
Even while calculating the values, if you got your R value is some greater than 1, then just check your calculation that there is some mistake.
Ma'am,
Yes.
is point biserial correlation coefficient is also an R.
No, like we denote it as a PB, RPB.
So the values of RPV could have greater than 1.
No. It is also less than 1 only. Less or equal to 1. It can be 1, but it can't be greater than 1.
Ma'am, I have a doubt in practice.
So do you know like when do we have to use correlation and when do we have to use point biserial? There is a one difference.
Correlation coefficient only uses between two numerical variable. It is in categorical and numerical.
Yes. So this point biserial is used when your data is given that one variable is your categorical variable correlation. Sorry. Coefficients. This is only used when your data is like there is one categorical variable is there. Categorical variable is there and one numerical variable is there. Okay.
And categorical variable should be only categorized into two.
Yes, exactly. It should be dichotomous only.
If there are three, then it could not.
Yeah. This is the condition you have to remember. Okay. So that's why we need this point biserial correlation. Otherwise, someone will ask, okay, we have already calculated the correlation, we have the formula for it. What is the need for this point biserial? So when the data is like that, one is your numerical variable and one is categorical variable, which has two categories, then you can use this point biserial correlation coefficient, because this will not work there.
Yes, ma'am.
Okay.
Ma'am,
Yeah.
is there any formula means in higher studies for 3 variable and 4 variables too?
Yes.
Okay.
But I guess this is not in your like
Yeah,
curriculum.
Ma'am, there is also something 0 less than equal to R and
0
less
less
than
than,
equal
sorry.
0 less than equal to R square or less than equal to 1.
That is best fitting offline. Yes.
Yes. That is capital R actually. It gives the extent of variation, goodness of it. Yeah.
Ma'am, can you explain goodness of fit briefly?
For this, we like have one lecture again. I guess tomorrow only. So that thing will be discussed there.
Okay.
Okay, ma'am.
Yeah.
Ma'am, I have a doubt in
Ma'am, in the
practice assignment.
qualifier question, ma'am, in the qualifier exam is very hard or moderate.
If you study well, the questions will not be hard actually. But yeah, the level will be moderate. You have to study well, then you will be able to answer all the questions.
Ma'am, I have a doubt in practice assignment 4.2.
Sorry, actually, I told now, like there will be a session tomorrow for this assignment questions and all this.
Okay, ma'am.
Ma'am, week 3 graded assignment also. This is a small doubt.
Yeah, you can ask there on. Okay, if there is doubt regarding this class today's class, please ask.
No, ma'am.
No, ma'am.
Okay,
Ma'am,
then we can end the meeting. Yes, please.
ma'am, in point by serial correlation, we have to use population standard or that. How we will get
Population
informed that
standard.
which one will.
Population
Always we
standard
will.
deviation. Yes.
Okay.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you.
Thank you.